You know that core belief we have in software engineering that more smart people means more speed? Well, we're about to challenge that. What if the opposite is actually true? What if the real key to going faster isn't adding another person, but building a better system? Let's get into it. I mean, we've all been there, right? You bring more smart people onto a project and you fully expect things to just take off. But what if that's a completely flawed assumption? What if every single new person you add introduces so much friction, so much coordination overhead that it actually tanks your team's productivity? Well, get this. According to some brand new research on advanced AI coding agents, that is exactly what happens. When two state-of-the-art AI agents team up on a coding task, their success rate plummets by up to 50% compared to just one agent doing all the work by itself. I mean, that is a catastrophic drop in performance.
All right, so here's our game plan for this explainer. We're going to start with this idea of the curse of coordination. Then we'll do a full autopsy on why these teams fail. We're going to show you why this isn't just a weird AI problem, it's a very human one too. And then finally, we'll look at the solution, platform engineering, and give you a concrete plan of action.
So this insane drop in performance, it actually has a name, the curse of coordination. And it's a phenomenon that's probably going to resonate with anyone who's ever been trapped in one of those endless planning meetings that goes absolutely nowhere. Now, this discovery comes from a benchmark called CooperBench. It was specifically designed to test how well AIs collaborate on coding tasks. And when they assigned two AI agents to work on related features, the finding was just stunning. Adding a teammate makes them dramatically less effective. This completely flies in the face of how we think human teams are supposed to work. So why? Why does this happen? Well, the researchers dug deep into the logs and they found three specific recurring patterns of failure. And if you've ever worked on a software team, these are going to sound eerily familiar. Okay, so the first type of breakdown is called an expectation failure. This is all about having a totally flawed mental model of what your teammate is actually doing. So what does that actually mean? Well, the crucial point is that even if one agent says what it's doing, its partner just acts as if that work isn't even happening. It completely fails to build a shared understanding of the system's state. You can think of it like two developers working on the exact same file, but each one has a completely different idea of what the final version is supposed to look like. It's a recipe for disaster. The second one is commitment failure, and this one is more straightforward and maybe, just maybe, a little more frustrating. It's really about not doing what you said you were going to do. It's as simple as that. The agents make these promises about the code they'll write or the interfaces they'll build, and then they just don't. And this isn't just some simple mistake. It's a failure to create what the research calls a verifiable integration contract. There's no proof. And this just illustrates the problem perfectly. Look at this. On the left, an agent says crystal clear, I will add a bypass check at lines 100 to 104. A little later, it proudly announces implementation complete. But then you go and you look at the final code, and the bypass code is just gone. It's completely missing. A total failure of commitment. And the third breakdown, you probably guessed it, is communication failure. Now, this isn't just about not talking. It's about the communication itself being totally broken. The communication just becomes noise. The researchers found agents sending these super vague messages, completely ignoring direct questions, or giving updates so late they were totally useless. You know, they're essentially just talking past each other, not actually coordinating with each other. Okay, now it's really easy to just dismiss all this as, a weird AI quirk. Oh, that's just buggy AI. But what if it's not? What if these failures are symptoms of a much deeper problem that applies to any system of agents, including the human ones? This quote is everything. The idea here is that these coordination failures, they're not because of buggy AI or because of flawed human psychology. No, they are fundamental information theoretic constraints on any system that's trying to coordinate. The dysfunction is independent of the substrate, and that's just a fancy word for what you're made of. It doesn't matter if you're silicon or carbon, these problems are universal. And this data makes the point undeniable. Look at this. A single agent, zero coordinating overhead, perfect score, 28 for 28. You add a simple hierarchy, one coordinator, the success rate drops. You have 8 agents all working at once, it plummets. And a gated pipeline super heavy with handoffs and reviews, complete and total failure, 0. The takeaway is crystal clear. The more complex the coordination gets, the worse the outcome is. So if adding more agents, whether they're human or AI, just cranks up the coordination cost and the risk of failure, what's the answer? Well, it turns out research from Google's Dora team points to a structural solution that the highest performing engineering orgs are already using. Dora's research found that AI assistance, a lot like adding a new teammate, it only helps when the underlying delivery system is already well designed. In those systems, AI acts like a turbocharger. It just amplifies productivity. But in poorly designed systems, it just adds more complexity and provides little to no improvement. It's like pouring sand in the engine. So what does one of these well-designed systems actually look like? Well, according to Dora, the elite performers, they consistently invest in things like internal developer platforms, standardized workflows, self-service infrastructure, and automated governance. All of these together, they form the core of platform engineering, which is a system designed from the ground up to structurally reduce that coordination overhead. Okay, so how does a platform solve the failures of expectation, commitment, and communication? The answer is by replacing all that ambiguous, messy, human coordination with clear, machine-enforced contracts and governance. Here is the roadmap. First, you formalize the interactions between your teams using explicit, machine-readable service contracts. No more vague promises. Second, you build self-service platform automation so that teams don't even need to coordinate to get things done. Third, you enforce those contracts and other policies with automated checks, not manual code reviews. And only then, once that solid foundation is in place, do you start layering in AI or more teammates to augment the system.
Okay, so this brings us to the most important part, the action plan. How can you actually apply these ideas to reduce that coordination tax on your own team, like starting today? Here is a practical checklist. Start defining your service boundaries with clear, typed contracts. Think open API specs. Automate your integration tests and your policy checks inside CI/CD. Find those manual handoffs between teams and see if you can replace them with a self-service tool on your internal platform. The whole goal here is to shift from relying on conversations and subjective reviews to relying on machine-verifiable proof. And all this leaves us with one final question. When you feel that pressure to scale your team or speed up delivery, maybe the answer isn't just to hire another person or plug it in an AI agent. Maybe the most impactful hire you can possibly make is an investment in a platform that makes everyone you already have dramatically more effective by finally solving the curse of coordination.